All right, guys, for the last question, part A is okay, part A is not so tricky, but part B just need a lot of work here. So part B, this 50 mark is not easy to get actually, but you will be awarded a partial point for all your steps. Okay, not even though you cannot get the final answer, we will reward points for each main step that you have completed. So you don't have to worry. You just do what you can, and then we will try to give you some point for the partial solution also. Okay, for the part A, it's about the Norton theorem. So you know the Norton theorem, we have the Norton current and the Norton resistance, right? And then they are in parallel, unlike the Thevenin theorem. For Norton theorem, we have Norton current and Norton resistance in parallel. So what you do is, but this case right now, this is not our output here. Usually our output at the right hand side, but for this question, the output is actually right at the center here. Okay, so this is our load actually. The 2K is our load. It's not considered part of the fixed circuit here. This is the fixed circuit here. 1, 2, 3, 4, 5. Not this 2K. This 2K is the RL, is our external circuit. This is why we measure the V out here. So what you have for your first step, okay, we need to find the Norton short circuit here, Norton current. Okay, Norton current short circuit here. I refer to the current right here, ISC, right? The Norton current flowing through the output. Okay. Eventually, you have one Norton current, the equivalent Norton resistance, and then the 2K is our output. So this is the variable circuit, right? It's called the external or variable circuit. This 2 is the fixed circuit, right? Okay. So we need to find the IN by looking at using the KCL at this node here. You can see this current is going in, this current going in, and this current going out. Okay. So you try to do some circuit analysis, okay, with a few components here. You try to find this IN. Okay, if you can find the IN, then for the next circuit here, you need to find the Norton resistance here. Okay, you find the Norton resistance, all the resistance in the circuit, Norton resistance, and then you put these two together, the Norton resistance and the 2K here. Okay, these two need to parallel. Then you can calculate the V out easily. Okay, so you can calculate V out after you're finding the Norton short circuit current here. So first you need to find this current, and then you can calculate the V out after you find the next variable, Norton resistance. Okay, Norton this Norton current actually, this Norton short circuit current, and this one, remember they are in parallel. So these two also parallel each other. So they need to okay, this one you can parallel these two and find the V out. Okay, V out equal to what? I think this is using Ohm's law, you know, right? Okay, so for this question is quite okay. I give the hints that the Norton's current here is a milliampere, and the Norton voltage is a something volt. Okay, for part B is a bit tricky because superposition is a kind of a tricky method here. Superposition theorem here. Actually, we seldom use in practical world. Okay, superposition theorem to find the Vx. So the Vx is the voltage across this 4 ohm here. The voltage across this 4 ohm is called the Vx. We try to find this voltage only using the superposition. So basically you need to perform 3 steps. For the first step, okay, for the first step, we assume this voltage is Vx. We assume this for the first step, we assume the voltage here, also set with voltage here, right? Voltage across this 4 ohm is called Vx. Okay, but for the first step here, we assume the voltage source short circuit. So this one short circuit here. Okay, here short circuit. Remove this one, short circuit. And the current source, open circuit. So this current source here, open circuit. So this open, take away this. So you have only 2 ohm here. After this branch, right, we only have 2 ohm and then join this node. Okay, but this 12 volt still here. This 12 volt is still here. Then you try to find a Vx. Okay, you find the first Vx. We call the Vx1 actually. Vx1 for the step 1. Okay, after you've done this, the second step, you take away this voltage, you take away this voltage, you leave the only 3 ampere in the circuit. Okay, and this node here now become Vx2. Now become Vx2, this node. Okay, one more time, for the step number 2, you take away the voltage source, you just leave the 3 ampere inside the circuit. Okay, that means this no more already, right? Because this open circuit, the 2 ohm no more already, right? Here's open circuit, all right? No current flowing through here. So if you remove this one, there's no current flowing through 3 ohm also, so you can remove this one also. So you leave a very simple circuit, right? Then you find a Vx2 at this node. Okay, and the third step here, you take away this voltage source, you take away this current source, and then you leave with only 20 watt here. Okay, you only leave this one alone. Okay, you only keep this one, you remove this current source, you remove this voltage source, so this one is no more because this open circuit here, no current, so this one no more. Then you find the third Vx3, we call Vx3. So at the last step here, Vx here is equal to Vx1 plus Vx2 plus Vx3. Okay, this method is called the superposition. That means at each step here, we remove certain current source or voltage source, and then eventually we combine all the voltage here to know this final Vx value. That means you need to perform 3 steps. Every step you need to remove certain voltage source or current source. Okay, so these are the 3 steps you need to follow. Okay, so the answer is Vx equal to something, okay, something volt. Okay, you need to add these 3 voltages to get this number. All right, this is for question 4.